Okay, so let's do this example with the uniform distribution. So I claim that the amount of time I have to wait for a pizza to be delivered is uniformly distributed between 20 minutes and an hour. In other words, any one of those times between 20 minutes and an hour is equally likely to happen. It's no more likely to be 25 minutes than it is 50 minutes. So that's a uniform distribution with a minimum of 20 and a maximum of 60 minutes. So I want to draw that PDF and then shade in the region that corresponds to waiting more than 45 minutes. Okay, so let's call this variable x, which is a uniform distribution that goes from 20 to 60. So it goes from 20 to 60. It doesn't really matter with my scaling here. And it's uniform, so it'll be flat here. I only need to find the height in order to do all my probabilities or percentiles. So remember, the height was 1 over the distance between these. So 60 minus 20 is 40. So this is 1/40. That's my height. And now I want to shade in the region that corresponds to waiting more than 45 minutes. Okay, there we go. And I assume the next thing I ask us to do is find the probability, so let's find that. So the probability that we wait more than 45 minutes is the area of this rectangle, which I derived a formula for in an earlier video. If you want to use that formula, fine. But I've already drawn the picture. I might as well just use it. It's just the width times the height. Well, the width is 60 minus 45, which is 15. And the height is 1/40. This will be 15 times 1/40, or 15 divided by 40, which I do in my head. That is 0.375. There you go. So the point of this is just recognizing that our probabilities, now that we're looking at specifically uniform but continuous variables, is just an area, and I can find that area because it's uniform by just finding the area of a rectangle. So let's look at another example. So this will be the probability that I get my pizza in less than half an hour. Okay. So I'm going to do the same deal where I kind of just shade it in. And if you've got those formulas written down, you can try just following along by using those. I just like making the rectangles. I never make a mistake that way. Sometimes when I've got a bunch of variables in my formulas, I end up making a mistake because I forget which variable's which or mess up the arithmetic somehow. I'm just going to work with it this way. So less than 30 minutes means any value less than 30, but of course at least the minimum. So somewhere in here, between 20 and 30. Well, this is just, again, the area of a rectangle. My width is 30 minus 20, which is 10. My height, still 1/40. So this is 1/4. Right? 10 over 40 is 1/4, or 0.25. All right, last one. Let's find the median for pizza delivery times. Okay. Well, I don't know that this time it's worth it to rederive the whole percentile thing. So let's use the formula for this. So the 50th percentile is going to be, well, let me just give you the formula again so we're all on the same page with this. The kth percentile is k over 100 times b minus a plus a. So the 50th percentile, which is the median, is 50 over 100 times the maximum minus the minimum, 60 minus 20, plus the minimum again. All right, so this is just a half, or 0.5. This is 40. I need to add on 20 again. So I need to find half of 40, which is 20. And then add on 20 again, and I get 40. Right, that's it. These are really all the kind of questions I'm going to be asking for the uniform distribution. These should be fairly straightforward, especially if you draw yourself a picture for the probabilities, and you'll just get practice a couple of times with the percentiles. It's fairly straightforward arithmetic.